Professor Gautam Gangopadhyay has been at the University of Calcutta since his BSc in 1988. His research area includes nuclear structure theory, mean field theory, resonance and bound states of halonuclei, nuclear astrophysics and nuclear synthesis, and experimental gamma spectroscopy. He is now a professor of physics at the University of Calcutta. He is also a regular associate of the Applicidum International Center for Theoretical Physics, Trieste, Italy. Outside from academics, his interests also include science fiction, history, popular science, and social work. For our first lecture for the day, we welcome Professor Gautam Gangopadhyay to talk on the topic Physics Research in Pre-Independence Calcutta, Some Forgotten Facts. We are honored to have you here.
Coming and thanks. I'm really grateful to the organizers of Cultvision for inviting me here. Am I audible?
Yes.
Okay. So we start with a more of an academic lecture, I suppose, but I'll try to avoid academic as far as possible. But this is, as you heard, that okay, I'm interested in history, and so it's some sort of journey in the last maybe 125 years or a bit more in the Calcutta physics. Now, this is slightly disjointed, and I will try to tie them in a thread later. If you look at the title, so I have added one word, that is near forgotten facts, because many of these facts, when I was creating the slides, I found that many of the facts were not really forgotten. So you see that we can start with the modern science started in India under the colonial rule, and in fact by the colonial. So you see that the first scientific institutions, all of them were surveys. So the survey of India, which started only 10 years after the Battle of Palashi. And this, why do you use surveys? Surveys are used because you see you need to exploit the resources of a country. And when the British are trying to exploit of the country, that is for their own benefit and not for the benefit of the Indians. So all these surveys and let us say observatories, all these were created for the benefit of the foreign group. It had some points, but you see that, for example, I'm sure every one of you heard that helium is an element which was found in the sun, which was first found in the sun, and in fact it was first found from this country itself, although there was no India involved. Then, for example, okay, then another thing is, first nowadays we talk of international experiments, but the first international experiment that India participated in was way back in 1761. So all over the world, scientists were observing the transit of Venus, because that actually, this transit of Venus measurement in 1769 actually gave us the scale of the solar system. Before that, we had some idea, but nobody really knew how far is, let us say, the sun or the Venus. So the size of the solar system was found in this experiment from the transit of Venus in 1769, and there is a nice story there, but I don't have time for that. So, so this is the first international experiment, and then, but all these things were basically by the British and some French and others. So if we think of the Indian science, of course, you see, they will start with the first three modern universities which are established in 1857, and then I will be talking about Calcutta University, more like of the Calcutta University Physics Department. So the first master's degree from Calcutta University was in 1863, but that was not in science. Then 1865 we had the MA in science. But remember that Calcutta University was not teaching those days. It was more like a big gigantic institution like the West Bengal Board or CBSE. So the university did not teach. The teaching was all done in colleges. For example, science was taught in Presidency College, science was taught in Dhaka University, Dhaka College and so on. And then we had this graduation in science. So it's still BA, but there were two degrees, BA-A and BA-B. And BA-B was science, and that started in 1872. And then we had a master's in science in 1885. The first batch came out in 1887. Then around 1898, the university decided that we need a degree of science. So they made a committee, the Science Degree Commission, and the members were, as you can see, perhaps Jagadish Chandra, Prabhupada Chandra, Manraj Sarkar, in whose name this hall is named, Alexander Patel, the famous chemist, and Father Lafo. And so BSc started in 1902 and MSc in 1910. There was Masters in Science, but it was Master of Arts. In 1910, we started giving the degree MSc. And the first, of course, the first education institution who used this is the Presidency College, now Presidency University. So this was founded in 1870, then it later bifurcated in a school and a college. And then the new building, which we now know, this came in 1874, and the physics department was shifted there. So, the 1887, I told you the first MSc batch from Calcutta University came out, and Ramendra Chandra Trivedi was the one who stood first. Okay. Now, I want to talk on teaching. So, in 1884, JC was joined, and then in 1888, December, we submitted two proposals to the Director of Public Instruction. One was for building an observatory on top of Presidency College, and this was very much supported by the officiating principal who just met him, Alexander Patel. And then another proposal was for, all this was submitted in December 22, for the upgradation of the laboratory in the Presidency College. And again, Patel, who was the officiating principal at that time, he said that he wrote to the DPI supporting his J.C. Bose's applications that I think I am right that if this is done, this Presidency College will be at par with most of the European colleges. But as you can understand, almost nothing was done. But the point I am trying to make is that J.C. Bose and later PCD, they gave teaching a very high priority. So J.C. Bose and PCD, I am leaving them right now because we all know what they did. So let us go to this place, IACS. So of course we know it's founded in 1876. It was something like 80,000, Manuel collected something like 80,000 from the donations of the Indians. And then of course there was a trouble for the final meeting because some people wanted a technical school and not a science institution. But there was a meeting in the Senate Hall of Calcutta University, and it was chaired by the Lieutenant Governor at the time, Richard Temple. And Richard Temple and Rajendra Lal Mitra, they actually supported Mandrolal, and so it was carried and this institution was made. Of course, it was much of a problem, so there was short of money, so Vijayanagar Maharaja gave 50,000, actually 25,000 was his own donation and 20,000 he collected from others. But this was of course not the building. That was in 2210 Bohu Bajar Street, where now the going up college starts. And that was actually an older building given by the British to Mandrolal. And Mandrolal passed away in 1904, and we all know that 1907, C.V. Raman started walking here or there. But again, I am living now. Just the other, across the road we have the Jadavpur University. So how did it come? So you know that partition of Bengal began in 1905 and, by Lord Curzon, and then that gave rise to a strong nationalist feeling. So National Council of Education, Shubodh Mollik and others, many others, will meet some of them. So they started this National Council of Education, and Bengal National College is started in 1906. But just like the case of the cultivation, there was a very strong disagreement, and this National Council of Education immediately broke after its initiation, and Society for Promotion of Technical Education came up. And they made a college, the Bengal Technical Institute, which is basically something like an engineering college. Now in 1906, all this was happening in 1906, but 4 years later, when nationalist fervor died down to an extent, the two got merged. And finally that gave rise to this university over there. Then we can talk about Bosch Institute. Of course, we know that because this Bosch Institute started this in 1917, he actually funded a lot of, he gave his own savings, all the savings that he had, but also he had support. For example, Indians gave something like this 2 lakh. I'm talking of money again and again. I hope I will be able to clear that one. But you see that we must remember also that other people help. For example, Sister Nivedita induced disciple of the famous disciple of Swami Vivekananda, Sarah Chaplain Poole. Poole was actually helped Jagadish Bose a lot, because some of you may know that Jagadish Bose actually had a patent for the Galena diode, and that was Sarah Poole was instrumental that in getting it. So Sarabul devoted for a period of something like 8 years, 1902 to 1910, something like $40,000. So how much is that? So you see, that is something like 2.5 times the Nobel Prize money those days, and that means that in today's money it will be something like 10 crores. So that's not a small amount. But now, as I told you, that I will be talking mostly of this on my department, my college, Science College, Department of Physics. So these are the two books that I have co-authored. This one is with my colleague Anirban Kundu and Rajinder Singh from the University of Borden book. And this one, unfortunately, this is not available in the country. This is published from Germany. So we decided to write a Bengali one, which is, in fact, in my opinion, is much better. My colleague Anirban and I wrote it. So now what we are talking of is that you see that from the, let us say, 1920s, the best institution, physics institution outside Europe and North America was the Science College, Physics Department Science College of the University of Calcutta. So we are trying to trace the fact why. Okay, this is something that Robert Anderson wrote in his book Nucleus and Nation. He was talking about much later period, turn of the century, where 1990s, where there are a lot of physics students coming from the same science college. But we are not skipping that. We are going to the old picture where it started. So it started in 1904, in the sense that Lord Curzon, when he became the viceroy, he started this. He introduced this Universities Act 1904, which is basically, as you can understand, was to extend government control over the universities. There was a lot of opposition, but there was some opportunity. Opportunity was that, you see, I told you that university did not teach. Calcutta University did not teach those things. This 1904 Act allowed the universities to appoint professors and start courses. And Ashutosh, who became the vice chancellor in 1906 to 1914, he took this opportunity. So from 1906, he started creating new postgraduate departments, but mostly arts. Because science teaching requires money. So he opened a department in Pali, opened a department in economics, opened a department in mathematics, but no science department. So actually the university asked the government of Bengal, the Bengal government in those days, that we want to start a college, science college, so we need some money. So what the government replied was that, okay, we have got your application, we don't have any money now, so there are lots of other applications. When we have money, we will consider it. So you understand that means that never. So Ashutosh very well understood that it means never. So he went to Indian donors, and these are the two gentlemen who helped him. I don't know whether you can see the pictures, but this is Taraknath Palit, and that is Rashbihari Ghosh. Rashbihari Ghosh is the one, after him the Rashbihari gave his name. So how Rashbihari Ghosh, there are two advocates, and Rashbihari Ghosh, Ashutosh was a juror, and Ashutosh was actually a junior of Rashbihari Ghosh when he started his career in law. So Taraknath Palit endowment was something like 1.4 million into installments, and Rashbihari Ghosh endowment was 2.35 million, so 14 lakhs and 23.5 lakhs, so 3 installments. But you must add that Rashbihari Ghosh gave 13 lakh rupees to the National Council of Education that is over there. So that's a lot of money. How much money I will try to explain. But the only comparison is the rupees 30 lakh that was given by the Tatas to start the Tata Institute of Science in Bengal, which is now the Indian Institute of Science. Now, with this money of this Palit endowment and Ghosh endowment, we had these professional chairs in physics and chemistry and other departments, physics, chemistry, botany, applied maths, Pantari. But one condition was that all the professors must be Indians. This was because the Tata Institute of Science gave us a vital lesson, because Tata Institute of Science appointed a lot of professors, all of them were British and all of them were celebrated. So it was required that they must be Indians. And of course, along with that, money for laboratory, money for scientific staff, money for other staff, money for foreign travel, all these were there. Money for building, the science college building was actually made with the money of Taraknath Palit endowment. So first group of scholars, we know of them, Ravindra Shah, S.N. Bose, Gyanchandra Bose, Gyanendra Mukherjee, Shishir Kumar Mittal. These were the first group of scholars. They also taught. Not only they did research, they basically research independently, there was no guide for them, and they also taught in the classes. So how much are the endowments? So there was one silver rupee coin was introduced, and that contained 11.66 gram of silver. So if you go to the market now and ask for the 11.66 gram of silver, it will cost something like 810 rupees today for piece started. So the present market, if you compile that, that means that the money that the two advocates gave to Ashutosh for the science college will be in more than 3 billion, more than 300 crores. So that's really, you can see that I'm not saying that exactly 300 crores. By my book it is more, but it may be 250 crores. But you see that sort of donation we are talking about. And also in 1921, there were 5 chairs were created from the donation, and these were 11.1 lakh from the Maharaja Kumar Khai. So again, all these is from the Science College, Calcutta University. So the first professor, first college professor of course was C.V. Raman, who also used to work here. And P.C. Rao was the first college professor in chemistry. D.M. Ghosh, about whom we will have a learn. So D.M. Ghosh, Devendra Mohan Ghosh, who was the first Ghosh professor in physics. Prafula Chandra Mitra was the first Ghosh professor in chemistry, and so on. And look at the first Khara professor. A single syndicate meeting passed all these names. So it was Evan Shah, Mennat Shah in physics, Gyanendra Mukherjee in chemistry, Shumati Kumar Chatterjee in phonetics, and Abhijit Tagore in Indian fine arts. I doubt if any institution in the world, for the country, has in a single city appointed such luminous personalities. And let us talk about 2 books. Perhaps we have heard of one of them. You see, this one is the written by, not written by. This is the papers of Einstein's relativity papers were for the first time translated from German to English by 2 gentlemen. That is Evan Shah and S.M. Ghosh, and that was published by the Calcutta University Press with permission from Einstein. And there was an introduction by P.C. Mahalanobis, Prashant Chandra Mahalanobis, who was a physics teacher in Presidency College, just 1 year senior to Shah and Ghosh. So this was again, why did they write this book? Because they are teaching relativity and there was no book at all. So for the students, they translated this book, and this went for a long time. Let us talk about another book. This was in 1928. Sommerfeld, Arnold Sommerfeld came to Kolkata and other places of India, but he gave a series of lectures in the University of Calcutta on the wave mechanics. So this is 1928. I remind you that in 1926 we got the Schrodinger equation. So just 2 years after that he got this, and those lectures were taken down by K.S. Krishnan and RSA, and they were published by the Calcutta University. Again, you see that this is a textbook for students, and this is, I suppose, I'm not sure, but I'm sure that whether it is the first book, but I'm sure this is among the first textbooks in quantum mechanics that was published from the University of Calcutta. Just another story. Sommerfeld, when he came here, so he went to this cultivation of science in Bhopal. So he used to take his diary. So his diary had a lot of good things to say about this cultivation of science and physics in general in Calcutta. He said that okay, they are doing so very well. Even Japan is not nowhere near it. But then there was one line in the diary: toilets terrible. So some things don't change. Let's talk about D.M. Bose. So D.M. Bose is the nephew of J.C. Bose, Jagadish Chandra. So who was a teacher in City College when he was appointed in the 1914 in the University of Calcutta. So he already by then here worked with 2 Nobel laureates in England. One is J.J. Thomson, the discoverer of electron. The other was C.T.R. Wilson, the inventor of the Dow chamber. So after appointment as a Ghosh professor has a condition that you have to spend 2 years abroad for research. So that was the condition for the Ghosh professor. So actually, D.M. Bose and Agarkar, who was the Ghosh professor in botany, both of them went to Germany in 1914, and the World War I started. So they were stuck there. Fortunately, because they were Indians, they were not considered any enemy alliance, and they were not interned. So they spent 5 years there, completed his PhD, and then came back and joined. He made the first cloud chamber in India. It's worked for a long time. It worked till 1941. So he was the best expert on India for a long time, for magnetism and transition type of. There's a law, the Bose-Turner law, which was now, of course, now it is supplemented by the Bethe and Hay. So then he worked on radioactivity, he worked on X-rays, he worked on solid state physics, he worked on cosmic. This will come later. And he was received the first particle physicist in India. So he was there in the Calcutta University in 1938. J.C. Bose died in 1937, and D.M. Bose took up the directorship of the Bose Institute next year. So we talk about a much later episode, of course, before the independence. So the cyclotron. So what about the cyclotron? So Shah was in Kolkata till 1923, then he went to Allahabad University, and then he came back in 1938. So immediately he came back, he started the curriculum on astrophysics, nuclear physics. And for that, you see that was the first time nuclear physics was being taught in India, and he found that you need a laboratory. So what do you mean laboratory? So he thought that you need a cyclotron. Now you see that cyclotron for some period, okay, maybe there are some youngsters, I can't see you. So cyclotron is basically a particle accelerator, so it is the ancestor of this large hadronic collider. So the cyclotron was just being built by them, and in 1939, R. Lawrence won the Nobel for this invention of the cyclotron. In 1938-39, Lawrence was a friend of Shah, and so what happened was that Shah requested Lawrence for a cyclotron, so that they were going to make a cyclotron. So where to get the money? So the Tatas were establishing the Tata TM with the Tata Medical Hospital in Bombay for cancer research at that time. So he told to the Tatas, Sadhuradi Tata Trust, for money. Well, that application is missing, but from the Calcutta University documents, what we have found is that he asked for something which is 1,20,000. And the Tata said, okay, we'll be giving 60,000 if the Calcutta University matches the grant. So then we have come across some documents in the Senate which says that Bidhan Chandra Ray, who was the member of the Senate and later the Vice Chancellor of Calcutta University, he was saying that okay, the cyclotron will cost certainly 1,40,000. This was a severe underestimate. Okay, you see that Bingham severely underestimated the cost. Perhaps he had some motive because he thought that if you ask for a lot of money, then nothing will be coming. So perhaps that's true. In fact, Bingham actually collected a lot. I don't know whether you can see, but for the Tata Trust, he got 90,000 or 60. Then from the Vedas, Krishna Trust, he got 60,000. From the Calcutta University, he got 4,62,000. From the Ranada Prashant Shah, who was a customs clearing agent, he got 45,000. I don't know whether you have heard of Sur Industries. There was Sur Fridge where you were very low. There was something called Sur Fridge, and there is a Sur enamel and painting works. So from the Sur Industries, he got 2 lakh for a position leadership. And for the government of India, it is just before independence and after independence, so he got something 88 lakhs. So the total will be something 18 lakhs. So and Shah said that you could put 1,40,000. So that's quite, you can say that there is a lot of underestimation. In fact, this was the picture of Shah. For example, Shah directed the first electron microscope being made in the country under Professor Nirojnath Dazdu. So I read a letter where Shah said that okay, we will make it in 3,000, we will do this 3,000. And finally it cost something 40,000. But it was the first electron microscope, just like this cyclotron is the first cyclotron in Asia. But Shah sent his student Bashanti Duru Namchudri to Lawrence to learn about cyclotrons. There he did his PhD under Emilio Seghda, another Nobel laureate. So BD actually arranged for the shipment of parts from America. So there is this company, I forgot the name right now. So there is this company who was supposed to make this instrument ship it. Now, after he returned, America joined the Second World War. So one ship which brought the magnet and the chamber came safely, but the ship which contained the vacuum pumps never reached India. People think that it was sunk by the Japanese. So the vacuum pumps, unfortunately the problem was the vacuum pumps could not be made, those sensitive parts could not be made in any Indian workshop. Shanti Sharu Bhatnagar was the director of BSI, the Board of Scientific Industry Research, now the CSI. So the BSI, Shanti Sharu Bhatnagar granted 15,000 to the Calcutta workshop, but it could not be made. So after Hiroshima and Nagasaki, you see the problem Shah faced is not, I am saying that okay, 1,40,000 is severe underestimate, but you must understand there are problems. First of all, you see that these machines could not be made in the country. Then Hiroshima and Nagasaki happened in 1945, and after that, technology transfer, particularly nuclear technology transfer, became almost impossible. I have read letters from BD to Shah, which says that Shah actually went to England and he was thinking of buying some equipment from the black market, just from the streets. And BD said, no, don't do it, it cannot work. Then the partition of Bengal, you see that at that time, of course, nowadays fee is a much less, but now at that time the fee from the students was a significant part of the income of the university. And because of the partition of Bengal, the Calcutta University lost a large number of colleges, and so the fee went down. And of course, with the partition, there was a lot of problems, as you understand. But what Shah was, so these are the problems that Shah faced, and so that means, and okay, I will come to that one later. But what Shah was thinking of was instituting an institute for nuclear physics inside the Department of Physics, University of Calcutta. 10 minutes. So, but you see that this was a problem, and then ultimately it had to be a separate institute. We'll come to this point later. And then the cyclotron, okay, this is the present picture of the cyclotron lying in our department, or rather in our campus. It's very dilapidated condition. So what happened? The Shah Institute became another research institute like this. So these are some of the pictures that these are some of the institutes that Shah built. I just got this because you see that, I don't know whether you can see, but surely you can see this. So this is outside, and Shah was the first director of this institute, and under him the institute shifted from Bhubajan to here. And this is, I don't know whether you can see this again, this is the CGCRI across the street. It was the brainchild of Shah again. So, I'll just make a few, 2 points. One is that 2 discoveries in the period in physics that we missed. Okay. So one is, if you look at that, there's 100, okay, we have a lot of new elements that we made. Element number 114, proton number 114 is called fluorodium. So who was Flora? If you look at the Wikipedia, it says that Flora was a Soviet physicist who is known for his discovery of spontaneous fission. Then other things, but spontaneous fission. Okay, now let us talk about the spontaneous fission. Spontaneous fission is simply breaking up of the nucleus by itself. Say uranium nucleus breaks up by itself. So Shanti, Shyamada Chatterjee, again who started the physics department at Jadavpur University, he was a student at the time of Devendra Mohan Bose Institute. So when fission was discovered, he started work on that. So then what he did was he brought a radium-barium source, his neutron source, and some uranium he brought from his own pocket. And then he was studying this. He found that even if you don't take them, if you don't take the neutron source away, still there was some fission. So he, at that time, D.M. Bose was not in Calcutta, he was in Darjeeling. So it was summer. So S.N. Bose actually was in Dhaka at that point of time, but he came back to for the summer vacation. So S.P. Chatterjee went to S.N. Bose, and S.N. Bose suggested that Paras was looking at breaking spontaneous fission. So you see, this was completely impossible, or rather nearly impossible in the Bohr-Wheeler theory, which he till today teach. So Bohr-Wheeler theory, but S.D. Chatterjee said that okay, we are going to estimate the process of spontaneous fission, and he found that lifetime of uranium spontaneous fission is somewhere 10 to 16 years. So he went to publish it, but D.M. Bose did not allow him. D.M. Bose came back and he did not believe his data, so he didn't allow him to. And so he withdrew the paper. It was never published. And just 2 months later, Fledov and Petride announced that they have got spontaneous fission, but their lifetime was actually worse than Chatterjee. Then you can talk of Bibha Chaudhary. Since I have very little time, I will just tell that Bibha Chaudhary was a student of Devendra Mohan Bose. She was the first woman student who took up physics research in the country, not really, in Calcutta University. So, Chaudhary was looking at some cosmic ray events. So the cosmic ray events were basically, they are looking at photographic plates. So if you go back on the story that we had this Yukawa in 1935 have predicted that there will be a particle between the mass of electron and proton between 200 to 300 times electron mass, which will be a force carrier of the strong force. Now immediately, of course, the Wilson got such a particle in 1936. Now in that, you see that 1936 paper, that year also Wilson got the Nobel Prize for discovering positron. But later we understood that it was not really that particle that you were looking for. So D.M. Bose and Chaudhary at that time, between 1940 and 42, published 4 papers in Nature on the study of cosmic rays, and they actually devised a method to measure the mass of the cosmic rays. But you see that you are still missing the Equa particle, and then Cecil Powell in 1947 got the particle, and then in 1949 Equa got the Nobel, 1950 Powell got the Nobel. But why I am telling you this? Because you see, the muon which Anderson discovered was a mass of something like 200 times the electron mass, and the which is the Yukawa particle, is something like 270 times the electron mass. Chaudhary and Ghosh, Biba and Devendra, they were actually getting masses closer to the pi. In fact, but they were not published. So two persons, Biba worked here for some time in this institution in this campus from 73 to 91. So in 92 collaborators, I asked two collaborators of me, Professor D.P. Bhattacharya, who used to be a professor here, and Pratibha Pal, who was a student here. I asked both of them that why didn't they publish? They actually had published, asked Biba, and they said that they were not sure. Because why they were not sure? Because they could not measure the mass very accurately. And why? Because of the Second World War, which had started at that time, they could not get good photographic plates. All the good photographic plates were taken up by the military. If you read the Bosch Institute transactions, then you find that there every annual reports for that time, they're saying every report says, okay, we are not missing photographic plates, we are missing good photographic plates. They could never be sure. So this was again some discovery that we missed. So this is, as I said, these are some disjointed facts. So perhaps what I wanted to, as I said, that conclude, it's not really a conclusion, but what do we learn from here, from these stray facts? You see, I did not really, but Raman actually in 1925 submitted a proposal for a research institute inside the Department of Physics. University actually agreed in principle, but the money could not be found. Had that been found, perhaps Raman would not have left Calcutta University and Calcutta. Anyway, the point is that both Raman and Shah wanted to make institutes inside the department. So what I am trying to say is that the PG teaching, okay, so this is my personal opinion, please don't take it otherwise, the postgraduate teaching and research cannot really be separated. Good, not really only my opinion, there are a lot of people who share this. So the point is that when we got independence and then Nehru Bhabha model, we had these research institutions. And in the research institution, we had very good scientists who were not teaching, and the universities were not funded, so we had a lot of students who did not have access to good teaching. So we had this thing is not really anywhere practiced anywhere in the world, almost anywhere in the world is practiced, that the research and teaching are separated. Nowadays, of course, you can see that some of you were students here in this research institution, so things are changing, but at least I believe that the slow pace of science in our country is responsible. Something that one cause that is responsible for this is the teaching difference between science and teaching and science. You see that I told you, J.C. Bose, C.V. Raman, S.N. Bose, even all of them give very importance to teaching. And the other thing is the autonomy. So if you look at the Calcutta University moments at that kind of time, you will see that the British members of the Senate and the Syndicate, they are trying to oppose Ashutosh in appointing, say, Raman or PCA or D.M. Bose, people like that. So every time there was a vote and the British voted against it. But the university had the autonomy. It was not the government which was directing the university. So university had the autonomy, and that autonomy, of course, Ashutosh had the money, but he also had the autonomy to start a center. And what you see that we need centers, no doubt about that. But Ashutosh waited 10 years to create a College of Science College, because he knew that you need money, you need people, you need building, you need laboratory to start sciences. Okay, there are lots of institutions mushrooming all around us, but most of them are maybe glorified or not, even not so glorified colleges. It is something different. University is something different from a college, and that must be understood. So you see that where do you have the vision? The vision of Ashutosh, what did he lead us? We all know that in 1930, what happened, that C.V. Raman got a Nobel. But you must also remember that year, the physics Nobel Prize had the shortlist was a shortlist of three persons. And two of them were from the University of Calcutta. One was Raman and one was Ibn Shah. So these I'm trying to say that this is the vision that should guide us, teaching research together and autonomy. And finally, why did I talk about money so much? Because you see that those days we were governed by a foreign government, and they were not interested in teaching science. Why should they teach science to us? But the people like Shubham Malik, people like Rajbir Ghosh, people like Takshan Patel, they understood this. And they gave the money without any profit motive. Taraknath Patel basically gave all his money, almost all his money. Okay. So they knew that society must support science. Unfortunately, the pattern here is that nowadays if you look around us, okay, you are very young, I should not disappoint, I don't like to say this, but you see that we need to do this. We cannot do this for our people. That the country, the science needs the country's backing. Science needs the backing of the society. It's possible, it's important. You cannot do science without money. You cannot do science without the backing of the society. Okay, this is, I think, all I wanted to talk about. And there was some small point that you see that there was this debate between the science and technical education, and you see that it cannot be separated. You cannot say, okay, I'll be doing IT just and develop our country. It's not possible. All things go hand in hand. Of course, all higher education needs money. But science needs money more because of its own pattern. In fact, after the World War II, before World War we could compete because there was not that much funding, national funding. But after World War II, starting from World War I, but after World War II, there was a lot of that developed countries poured a lot of money in the science. And if we want to go to the forefront of science, our society must support it. Thank you very much.
Thank you so much for that very enlightening speech. And I'm sure we all got to learn a lot of new things today. Let's have a huge round of applause once again.